Generalized. What did I do here, generally speaking? Pick points closer and closer. I'm going to call that a variable, and I'm going to say that's delta x. That is going to be the point closer. Right? That's what that means. The close point. Just a little tiny, how far I'm off of picking x? Because we picked x, and then we picked something a little bit more than x, right? Okay. So then I'm doing my slope, right? My slope, generally speaking, is y2 minus y1 over x2 minus x1. With me so far? With me? Okay. But how did I so this would be f of x, right? Sorry, this is f of 0. Is that okay with you? F at 0. And this down here was 0. Right? Every single time it was 0. So far so good? Okay. If delta x is how much I pick away from 0, if delta x is how much I pick away from 0, then this right here would be delta x. Agreed? Whatever I picked, right? If I picked 102. Now really it's 0 plus that little bit of delta x, but it's just delta x. Agreed? Okay, you just nod your head. I don't know. Because you nodded your head earlier, and then you didn't have the foggiest idea what we're doing. Are you with me? Because what I'm about to do is going to be horrifying if you're not. You're going to get stuck. You'll be halfway through. You're like, I have no idea what he's doing. He's drawing on the board. He's making up letters. Yes, ma'am? We plugged in an expression, and we got 2. So we kept putting 2 up there, right? That makes sense? And then the 0 on the bottom. That's our x value, right? Our x value was 0. We're plugging in x for the bottom of the slope, right? When x is 0, or y is whatever that would be. Okay. Someone with me? Yeah, so f of 0 is... When you plug in 0. Which in that case would have been 2. With me so far?
Wait, do you always start by plugging?
Do you have a question? Yes, ma'am?
Do you always start by plugging in 0?
No, I'm going to explain all sorts of things here. We plugged in 0 here, so we're using 0.
Case. Okay.
But I want you to hold on to that question, because that's after we get done with the first wave, that's the next question we're going to ask. Why are we picking 0? Why do we pick another number?
Okay.
Yes?
So is the function, could you like put it as f of x over delta x minus x too? So
Too early for that, because we're using 0, so we just plugged in 0. We plugged in 0 in our function to figure out what this number was, didn't we?
Yeah.
Now, that's the same question she just asked. Give me a second, I'll get there. I'm not there yet because we're stumbling slower than we should be. But we're there. Good so far? All right, Ms. Resendez, are you with me? This is about to get horrible. We plugged in a delta x here, didn't we? How did we figure out what this number here was? This 2.01, where did that come from? This 3, where did they come from? We plugged in delta x into that, didn't we? So this right here is f of delta x. Would be so far? We plugged in our little bit x.
Do I have to be following this?
I would hope so. And then we got a minus sign, right? So we plugged in whatever value we had, 1, into the function to figure out what f of 1 would be. We plugged in 0.1. We figured out what that was. So are we? Okay. Then what did you do? We found the slope. This is the slope. And then we got our answer. Then what did we do? We picked another one, closer, right? What did you just call that a second, Leontio? Taking a limit. We took a limit as delta x approached what number? 0. We took the limit as a delta x shrunk towards 0. Did we not? Now, that's all cool. That's good. I want to clean this up just a little bit. Okay? Does that make sense? So far, what we did generally makes sense. Not I'm ready to do this tomorrow and let me do this 150 times. I'm ready to go, Mr. Rizzi. I understand what we're talking about. Okay. We found the slope by plugging in the point we cared about. Right? The point we were interested in finding the slope at. We added a little bit more. So can I clean this up by saying, can we write this as 0 plus that little bit more? Is that okay with you? Minus the 0, right? So far with me? We plugged in a little bit more than 0 is what we plugged in there. And then on top, we had f of 0. So far, that didn't change anything. And then, of course, what we really plugged in was f of the point we cared about plus a little bit more. And we then took the limit as delta x approached 0. So far with me. And that's what we did. Clunkier this way than that way, though. Right? That way felt better. Why do it this way? Ms. Cohn, what was your question?
Why do we always plug in 0?
Do we always plug in 0? We plugged in 0 because we wanted to find the slope at 0. What if I wanted to find the slope at 2? All the zeros in this expression we replace with 2. What if I wanted to do it, Ms. Cohn, for any value of x? What would I plug in there instead of 0?
Any value of x. Or
X.
Yeah, x.
Right? Whatever that value would be, that's what I'm going to plug in there. And so I would write the limit as delta x approaches 0, because that's still not changing, of f of, instead of 0, I'm going to plug in whatever value of x I run into. Instead of 0, whatever value of x I care about, divided by x plus delta x minus x. That's a lot of x's. Now, one thing just to clean this up, this will work for any value of x, right? Not just 0, not just 2. Any value of x I pick. One thing to clean this up, though, isn't x minus delta x always going to go away? So isn't the limit as delta x approaches 0, f of x plus delta x minus f of x all over delta x? This is what the slope is for any value of x.
That's our new formula.
That is called the formal definition of a derivative.
Do we put that under?
That is our new formula. The formal definition of a derivative. How the heck does this work? Does it work?
Is it delta x as the limit approaches delta x of 0? Or
Delta x approaches 0. Limit is delta x approaches 0 of f of x plus delta x minus f of x all over delta x. How does this work?
Plug it in.
Let's try it out. Let's take it for a test drive. Let's take it for a test drive. I want to find the slope of that little beast over there. You ready? Ready?
T squared plus 2.
T squared plus 2. Let's see if it works for this nonsense. So I'm going to plug it in. Limit. I'm going to call this as delta t approaches 0. That's why I switched to x. I'm going to get this worksheet better someday. The function. So the function is t squared plus 2. Agreed? So everywhere I see a t, I'm going to replace it with what, Ms. Resendez? I'm going to replace it with a t plus delta t. So I'm going to go t plus delta t squared plus 2 minus, what's the original function? T squared plus 2 all over delta t. Oh, we're not taking something. Yes, ma'am.
Just keep going.
Just keep going? Maybe. All right, let's keep going and we'll get it right. Now, how do I do this, Miss Reed? From last chapter, we spent a whole chapter learning how to take limits. For this moment, right? Here's the only reason we learned how to do limits last chapter. This is it. How do I take a limit?
All right, so we're gonna. Well, so what value of t are we doing? So
Any value of t. She said, and you said, can we do this for any value of t? I said, yes, let's do it for any value of t. That's what we're doing. It's your fault.
So do I just choose any value, or?
No, you can't choose any value. We're going to simplify this expression like we spent a whole chapter learning how to simplify it. We're going to find the limits. We're going to do what we thought we did last chapter.
Okay.
So how do we start? What's the first thing I do when I try to find the limit? Somebody tell me how to find the limit first thing. Other than Pentecchio is busy checking out his pants or his cell phone, one of the two. This is the moment, dude. This is it. Okay? This conversation. Yes, I'm going to get to the finish line. Yes, there's going to be an answer. Yes, it can be like really super easy. Then later on, they're going to ask you, what you're doing. You're like, I don't know. I was looking at my cell phone. How would I know? Yes, ma'am.
Okay, so the f of x function.
Yeah?
Subtract. the-
Okay, you're getting way ahead of me. We plug in 0,
Oh, right.
and we get t squared plus 2 minus t squared minus plus 2. Oh, gosh, that gives me 0 over 0. Oh, it didn't work. It's never going to work. We're collapsing to 0, right? You put the same number on top of it, go 2 minus 2 over 2 minus, it's always going to give you 0 over 0. It's always going to happen. Nothing you can do. You can't pick the same point. So it's never going to work. So then step 2 is what?
Try to simplify.
Try to simplify so we can cancel out something, right? That's the game. It's always going to work, which is nice. Limit as delta x approaches 0 of t squared plus 2t delta t plus delta t squared plus 2 minus t squared minus 2.
Whoa.
I had to foil. Foil? Do you have to show you the foil? Okay. Anybody need me to see the foil? Because I just foiled that.
No.
People struggle with foil. Okay? Yes, ma'am.
I just don't see how you plug that in.
I didn't plug anything in so far. All I did, oh, wait, back up. When it says I'm supposed to do the variable plus a little bit more, I just replaced everywhere you see the variable, I'm going to apply the variable plus a little bit more. Right? So this is this expression where I replace t with t plus a little bit more.
But shouldn't f of x be t squared plus 2?
It is. It's t squared plus 2. But I'm replacing the t because it says t plus a little bit more.
Oh.
That's what I did. I replaced the t with t plus a little bit more. Yeah? Pinto's not quite there. She's close. Look, it says replace it with a little bit more. So replacing x, usually it's x, in this case it's t. Replacing t with t plus a little bit more. T plus delta. This is, okay, this is replace x. Remember that's what we do with f of x? Remember we spent some time on that too, right? What do I redo? Everywhere I see an x, I replace it with plus delta x, right? So I went in the expression and replaced it with t plus delta t for the first part. That's this. Minus, write down the expression. Wrote down the expression. Because t is squared. No choice. The function squared, right? So I'm putting it in where the function is. Okay, I got to pause the